Hello friends, my name is Amit Sethi. Namaste and welcome to your own channel Storage Infra. In today's session, we will learn about how to create a Windows host object in IBM FlashSystem. You will see how to identify WWPNs, how to create a fiber channel host object, how to map volumes, and finally access that volume on a Windows server in Multipath environment. Let's get started. To complete this exercise, we will need access to IBM FlashSystem for provisioning. A Windows server will be used to connect and access the volumes. Another Windows server will act as a jump server. Let's access the jump server. From the jump server, connect to the IBM FlashSystem using the provided admin credentials. Switch to the Windows server that will receive the vdisk. Identify the WWPN on Windows host using the sdddsm command line tool, or if you have MPIO, use that. Use the command datapath query WWPN to retrieve the WWPN from the Windows system. This displays the WWPN of the installed HBAs. The command will list the 16-digit WWPN string. Record the last 3 bytes of each WWPN for future reference. Switch to the IBM FlashSystem GUI. Navigate to the host. Under host, select host again. Click on add host to define a fiber channel host. Specify the host name. I'm specifying Amit-host for the exercise purpose. You should follow your company naming convention policies when creating host devices. Select fiber channel as the connection type and select both the WWPNs from the drop-down menu for host port WWPNs that you recorded earlier. Select generic as a host type. Leave the IO group to all, which is default option. Review the configuration and click add. The GUI displays the svc task mkhost command that is used to create the host object. Observe this command. Once done, close the confirmation window. Let me add win to the host name for identification purpose. The new host name is Amit-win-host. To view object details, enable the ID column by right-click on the column header, right-click on the newly created host object, select Properties. We can also find Properties option in the Action menu. Explore the host properties and then click Show Details. And observe, by default, the host has access to all IO groups. In the Port Definition tab, verify that both WWPNs are logged in and currently in inactive status. Close the host properties window. Now let's create and map the volumes to this host. Navigate to the volume section and click Create Volumes. Select the child pool we created in the previous session. Update the quantity as 2 volumes. Specify capacity as 6 GB for each volume. Volume name is Amit-win. Starting range is 1. We'll create Amit-win1 and Amit-win2. Capacity saving is none. IO group is automatic. Review the options that we have just selected. After this, we will click Create and Map. The second option is there next to Cancel button. Review the 2 commands displayed there, svc task mkvdisk and mkvdisk host map. So observe these commands. They will be also available in the audit log section of your svc GUI. You can also access this from the CLI. Audit log basically. Click Continue. Select the host option in the Create Mapping window is there. Select the Windows host that we just created and click Next. Observe the highlighted Windows volumes and now click Map Volumes. Now again observe the mkvdisk host map command generated to map each volume to the Windows host. Take a note that the command used host ID. Click Close. This will take us back to the volume page. Let's sort by name. Just to ensure the host and the volume names are different and easily identifiable, I will rename the volume here. Though the volumes are being formatted with zeros in the background, they are still online and available for use by the host. Let me rename the volume. So we created Amit Win 1 and Win 2. I'm renaming it as volume 1. And this one I will rename as volume 2. Once the rename task is complete, scroll right and note down the unique identifier of the volumes. Then scroll more right and observe that both the volumes has host mapping status yes, which means they have now been mapped to the Windows host. So this is the UID, and just next to this there is host mapping which says yes. So we will switch to the Windows host and discover these mapped volumes that we just created. So if the new disk are not available, let's rescan the disk. From the Windows server, let's run the command data path query device, and the new devices are not available. In AIX we will run cfg-mgr. Here in Windows server we will open the server manager, access the disk management, right click the disk management and select rescan disk there. So this will discover both the newly provisioned disk once the scan completes. Waiting for the scanning procedure to complete. Now the disk have appeared there. So two new disks of 6 GB each are there now. If you see the difference, this is highlighted with a black title bar, and the one that is already there or configured is with a blue title bar. So both the disks are found and are in not initialized state. So verify same thing using data path query device command in IBM SDD DSM command line tool. The command list device names, type as 2145, which represents IBM store-wise family or IBM SVC. The serial number for each disk is visible there. So running the command will initialize the disk and make them online. Validate the disk serial number. It matches to the vdisk UID, that is a unique identifier from IBM FlashSystem. The size also matches. So the size and the matching UID proves that these are the same disks that are provisioned from the IBM FlashSystem. Let's create simple volume in Windows from these disks. Observe the unallocated 6 GB Windows Basic disk. Right click the unallocated space and choose New Simple Volume. Accept default values and simply click Next. Repeat the step for both the disk and confirm that both are visible with new labels. Let's finish the wizard, and both the disks are configured now. You can change the volume label if required. For example, you can use the vdisk name as the volume label, or what is the data type there. You can use that as well, what data you plan to store there. Access the device manager and notice there are only two IBM 2145 disks under disk drive. This shows that this is being controlled via Multipath. Return to the STD DSM interface and verify the number of paths for each disk. This is how multipathing controls the LUN paths. The number of paths depends upon zoning. Let's access the disk and copy some data there to view the live performance matrix sample. Return to the IBM FlashSystem GUI to observe the write performance matrix once we start the copy. Keeping the performance page ready to view the performance once the copy is happening. Switch back to the Windows server, copy a 4 GB file to the newly mapped drive, and then later notice the spike in the performance matrix on IBM FlashSystem. So right now we are copying the data from the existing drive to the new drive that we just created, the 6 GB drive. So we are copying 4 GB data to the 6 GB drive. Switching back to the IBM FlashSystem, and let's notice the performance matrix for MDisk, interface and volume section. It will show the progress, or it will show the spike while the data is in copy. It will drop the spikes once it completes the copy process, as data writing will stop. Volumes represent the virtual disk provisioned to the server. Interface in the flash system represent the fiber channel ports that are being used to connect the volume to the server, and MDisk is the backend storage where data is actually being stored. Copy process is complete. Now the spikes will go down. All three sections for volumes, MDisk, interface, all shows how the data I/O was happening. The CPU utilization has been stable all this while. There is no impact of any processing happening on the server level on the CPU. Let's also view the host connectivity in IBM FlashSystem. To view that, we will navigate to the fiber channel connectivity section via network page. Let's move to the host connectivity, navigate to the settings, network, fiber channel connectivity. Let's filter by the host from the drop-down menu and select the Windows host from the list, and let's click Show Result. Local WWPN refers to the WWPN of the IBM FlashSystem node canister, and the remote WWPN is the WWPN of the host device. Let's organize a little to correlate. Observe how each WWPN is zoned with both node canisters of IBM FlashSystem. So the number of paths that a host is accessing a volume via is controlled by zoning. The first and fourth row shows WWPN ending with 703, which is zoned with both node 1 and node 2 of IBM FlashSystem, providing 2 paths. Similarly, the second and the third row shows WWPN ending with 701, which is also zoned with both node 1 and node 2 of the IBM FlashSystem, adding 2 more paths and thus providing total 4 paths for each volume for the host. This also confirms successful zoning and path redundancy. With this, we conclude the session on creating and mapping volume to the Windows host via IBM FlashSystem. Thank you for watching this session on IBM FlashSystem. I hope this explanation was useful to you and it adds value to your learning journey. In case if you want me to cover any specific topic in upcoming videos, you can leave your thoughts below in the comment section. Also, don't forget to share, like and subscribe the channel. Your support helps me reach more learners and it motivates me to keep creating detailed technical content for you. Stay tuned for the next video where we will explore more about the IBM storage. Till then, keep learning, keep growing. Take care.